Hello there, you beautiful people, and welcome to this project where we're going to be making a game of tic-tac-toe, noughts and crosses, XO, 3 in a row, whatever you want to call it. You've most likely played it, and it's going to be epic. So this is going to be quite an involved project, and it's going to use a lot of what we've done so far. As we're getting towards the end of the course, I'm going to step up the difficulty to show you what's possible, and also really use those pieces of the course that perhaps you might have forgotten. So it's going to be a good reminder as well. Now, if you follow along, even though it will be hard, by the end of it, you won't recognize yourself. You'll be so much better at programming Python than you are now, and will have built, with your own hands, a very playable game, and will totally be a great Python programmer. If you're ready, let's jump into it. So I've gone ahead and created a script called game.py in the usual place, and we're going to start off by making the board. So how can we make a board in Python? Well, the board, if we think about it, has 9 spaces, right? 3 columns of 3. So the data type that we need to use to make the board needs to be able to hold multiple things inside of it. So we're going to need a data structure of some sort. So that means if we're going to use a data structure, we're going to use a list, a tuple, or a dictionary. So which one is it? Well, the board can change as, players make moves. So therefore, we can't use tuples because tuples are unchangeable. And the simplest way to access each of the spaces would be to use a number, just to number each of the spaces. And because lists allow us to access elements using numbers, we're going to use a list. So we're ready to go. Our board is going to be just an empty list to start with and needs to have 9 elements. So what we could do is we could type board equals and give it blank spaces like this 9 times. But I'm quite lazy, right? I don't really want to type that 9 times. So what I'm going to do is I'm going to use a list comprehension. And I'm going to say, give me a blank space for I in range 9. And that's that. Now, I isn't actually being used, but this loop is running 9 times. And it's giving me a blank space. Okay, so that's going to give us a board with 9 blank strings in it. Brilliant. So if I print this board, you should be able to see that. There we are. 1, 2, 3, 4, 5, 6, 7, 8, 9. Told you list comprehensions were useful, right? So let's just close the shell. Okay, so now we have our empty board. But when I run this, right, it doesn't really look like a tic-tac-toe board, right? A tic-tac-toe board is a grid, is a 3x3 grid. So we want to actually see something like that if this game's going to be believable. So let's just head back over to our function. And the way that I'm going to have this board printed is I'm going to use a function. Okay, and I'm going to define that function. I'm going to call it print board. Now, to create each of the rows, I'm basically just going to print a string. So row 1 is going to be a string of blank, blank, blank. Now, if you're wondering where I'm getting these, they're called pipe symbols. On my keyboard, it is, I press shift and I press the key next to the letter Z. So it's just above the backslash on my keyboard. Yeah, I can't help you if it's not in that position, but just look for the pipe symbol on your version of your keyboard and you should be able to find it. Now, in each of these, this is going to be the first space of the board. This is going to be the second space of the board. This is going to be the third space of the board. So to do that, I'm going to format board 0, board 1, and board 2. Okay, so that's row 1 as a string. I'm going to copy and paste that onto the next line, making sure the indentation's the same. Did you see how it was indented 1 across? That would mess Python up, okay? No, it has to all be in line. So row 2, it's going to be board 3, board 4, board 5, and one more time. Okay, so row 3, we're going to get board 6, board 7, and board 8. Okay, now to actually make it print out, we're going to print a blank line, print row 1, print row 2, and print row 3, and then finally a blank line underneath the board. And these extra blank lines here are just to make it look nice. Okay, they don't really do anything else. So that's our function. Let's go save that. Now when I print the board, when I run the print board function, all of this code's going to run. And what we're going to see is we're going to get our beautiful tic-tac-toe board on the screen. How nice is that? Now this code is slightly repetitive, right? I could write a for loop to print this out, but because it looks so beautiful, I think we'll leave it just as it is, don't you? Now down here, we're going to have, instead of this print board, we're going to have a while loop that basically runs forever, so the game will continue to run. This is in game programming, this is called the game loop. Okay, and basically the rest of our code is just going to go inside of this. So player 1 is going to play as X. Now we need to ask them where they would like to place their move. If the player enters 1, they're going to move to the top left. If the player enters, I don't know, if they enter 5, they're going to go here. Okay, if they enter 8, they're going to go here. So just imagine these blank spaces being like the numbers on a telephone. 1, 2, 3, 4, 5, 6, 7, 8, 9. So to ask for this move, we're going to create a variable called choice, and I'm going to ask for the input, enter your move 1 to 9. Okay. Now I'm going to want to strip away any white space, and because these are numbers, I'm also going to convert it to an integer. Okay, so now we're going to get a number of actual integer data type inside this variable here called choice. So we can now update the board with that move. But there's something we need to bear in mind, however. Because of the fact, the way that the Python list, its indexes start from 0, if they enter 1, to move to the top left, we actually need to say that that is board index 0. Okay, so we need to actually enter an X at the index below their choice. So what I mean is, instead of writing board of choice equals X, we actually want to write board of choice minus 1 equals X. So when they enter 1, 1 would be choice, 1 minus 1 is 0, and that is what goes there. Now actually, before we run this, what I'm going to do is actually up here, I'm just going to change this into 2 spaces. And the reason I'm going to do that is just to give a little bit more space inside of our board. So now when I run it, we're going to see our board pops up, and enter your move. Let's say we want to go straight into the middle. Okay, so we're going to 5. Bang, there pops up an X. So what if I want to go at the top right? Type in 3. There that is. And come on, let's just win a cheeky game. Go number 7. And there we go. And we can stop this by pressing Control and C. So that's amazing, right? We've now got a updating board depending on which, when you enter your moves. But what we need to do, we need to make this so that you can only enter a move when that place is empty. Okay, so for that, we're going to need to check whether our board holds an empty space or not. So right here, we're going to say if board of choice minus 1 is 2 blank spaces, because I've got 2 blank spaces up here, then if it's empty, basically we're going to say board of choice minus 1 is going to become an X. But otherwise, print a blank line and say that space is taken. I'm going to remove this extra line of code here and save that. So what's going to happen is now we're going to have our empty lit thing. I'm going to go straight in the middle, and it's going to go fine. But if I try to press the same space again, it's going to say that space is taken, but it still remains our move, which is kind of just like real life. So we've made a lot of progress in the game so far in this video. We've made the board, printed it to the screen, and allowed player 1 to make valid moves. So that's quite great, right? Now up next, we're going to continue working on our game and get player 2 into it. So I'll see you in the next video. Hello there, you beautiful people. So let's continue working on our game. Now in this video, we're going to make it possible to process moves for player 2. Now when we process moves for player 2, it's going to be basically the same as for player 1, right? So what I'm going to do is I'm going to create a function called player move, okay? And the reason I'm creating a function is because I don't want to just be repeating myself. I just kind of want a general function that's going to do a move for a player. And I'm going to give it a parameter called icon. Okay. Now inside of here, I'm going to move all of this inside of there. Okay. And instead of just printing X for every player, I'm going to print that icon. So, for example, if I did player move and I gave it the icon of X, that would mean that it was the X player moving. And the processing is going to be exactly the same. If it's a blank, then you can put that icon there. And if it's not blank, then the space is taken. It doesn't matter whether it's an X or an O, the game works exactly the same way. So, but one thing we do want to add is we want to tell the player whose turn it is. So let's say print your turn, player, like that. And we're just going to put in the icon. So whatever it is, it might say your turn, player X, or your turn, player icon. Or what we could do, actually, is we could have a an if statement. We could say if icon equals X, number equals 1, else if icon is O, number equals 2, and you go your turn player number. Okay, so now it's going to say your turn player 1 or your turn player 2. So that's good like that. Let's save that. So let's run this. Okay, actually no, let's not run it just yet. First, what we need to do is in here, when we've printed the board, we're going to say player move X. Then we're going to print the board to show what happened, and then we're going to do player move for the O. Now when we run this, okay, it says your turn player 1. We can see that it's moving. We can see this working, right? So let's start with the X, go straight in the middle. Popular tactic that. It's going to say your turn player 2. Let's say we want to move up to the top left. Or top right, sorry. And there you go, actually. So we can see that that is working fine. Now we've got an O in that place. Let's say we want to move the X down 1. That's moved there. And then we want to move the O right there. Okay, so we're getting the game's working, right? And if I try to move on top of someone else, let's say I want to move on player 2, it's going to say it's not possible for both of us. So we're doing well. So I hope this highlights to you just how important functions are, right? We've managed to write a function once, but made it general enough that it's worked for 2 players. So I hope that really helps you figure out how useful functions are. Our next step is that we need to check whether someone has won the game or not. So let's make a function called isVictory. Okay, define isVictory. And we're going to give it the icon here. So instead of making a function saying did X win or did O win, we're just going to say is it a victory for that icon. Now how do we know if someone has won? Well, there's 8 ways to win, right? They can have all of row 1, they can have all of row 2, or they can have all of row 3. They can have all of column 1, column 2, or column 3, or they can have either of the 2 diagonals, which makes 8. So this is rather simple to program, it's just a bit repetitive, but copy and paste is going to do the job. So let's check if they won on row 1 first. What we need to do for that, if board 0 is equal to their icon, and board 1 is equal to their icon, and board 2 is equal to their icon, then you know that means they have row 1. and they'll win. But what we're going to need more space for the other 7 conditions. So let's break up this if condition on more than one line, and we can do that by using a backslash. So I'm going to say or, and then type a backslash like that. And you can see the way Python's kept us all nice and in line. So let's do it for the other rows as well. So let's copy and paste this. The second row is going to be board 3, board 4, and board 5. And we're going to say or like that. Now let's do the last row. So board 6, board 7, and board 8. Okay, so that's all of the rows. We now need all of the columns. So for all of the columns, what we're going to need for that is we're going to need board 0, 3, and 6 for the first one. So that's column 1. We're going to need, for the next one, we're going to need 1, 4, and 7. Oh, that was fine, actually. 1, 4, and 7. And we're also going to need 2, 5, and 8. 2, 5, and 8. Okay, so now for the diagonals, we are just going to want to have 0, 4, and 8. And for the other diagonal, going to have 2, 4, and 6. All right, so that's how we're going to check if they win. So if either of all these conditions are true, then actually I don't need an or there. I'm going to put that colon. If either of these conditions are true, we're going to just return true. Otherwise, return false. Okay, so this function is going to give us back true or false. It's going to give us back a Boolean. Now, to make this work in our game, we need to check for a victory after X moves and after O moves. So let's do X first. So X is going to move. We are going to put this here. We're going to say, okay, we should print the board first. So let's check if it's a victory after that. If it's victory for X, we're going to print X wins. Oops. X wins. Congratulations. And break. And this break is just going to end. It's going to break us out of the while loop. Okay. So that's just basically going to finish the game. So if X has a victory, this is going to give us true, which means the condition here is going to be true. Notice how you can use a function to give you a Boolean rather than just using a normal conditional operator, which is a really useful thing because you can define how you're going to get your Booleans depending on the conditions that you want. So if X wins, this is going to be true and this code will run. If not, we're just going to let player O move. So the only difference now when player O moves is purely for formatting reasons. We're going to need to put a print board inside of this victory condition. So what we're going to do, just purely for formatting things, so let's just pull this over one. Again, make sure the indentation is right. Actually, no, sorry, that needs to be in there. That does need to be in there, inside the if statement. Now, inside of here, we're going to put a print board. We're going to check the O victory, and we're going to say O wins. Okay, so let's have a look to see how that works. So we're going to say X is going to go there, O is going to go there, X is going to go there, O is going to go there, and then X is going to win by just going on 8. And it's going to say X wins, congratulations, and the game will finish. And hopefully the same is going to work for the O, so let's check that. Okay, so we're going to have X is going to go in number 1, O is going to go number 2, X is going to go number 3, O is going to go 5, X is going to go at 6, and O is going to go in 8, and it's going to say O wins, congratulations, and show us a thing. So fabulous. We have we now have a fully working game. But one thing that we know that happens quite a lot in the game of XO is that there's draws. Okay, so you just, most of the time, the game draws. And so we need to make another function called isDraw. Def isDraw. And how do you know if there's a draw? Well, the game draws when there's no space left, right? So what we're going to do is we're just going to say if the double space is not in the board, then, by the way, is that going to work? Yes, it will, because we've defined the board as global, right? So the global variable is going to be in here. If double space is not in the board, then return true, because that means the board's full. Otherwise, return false. Simple as that. So we're going to check for the X victory. We're going to check for the O victory. And then right at the end here, we're just going to say if is draw. Oh, sorry. We're going to say... actually, we're going to... Yeah. We're just going to check here. elif is draw. We're going to say print it's a draw. And we're going to break. So the reason I put it here is because X could move, not win, and the board be full. Okay, so we need to check if the board is full before we let player O have a go, because otherwise the player O could be playing on an already full board. And I'm going to do exactly the same down here. Okay, so we're going to let O move. If he wins, then great. If it's a draw, then stop the game. Otherwise, just go around and let X have a go. So awesome. We know if I run this, that should be pretty much a fully working game. Let's have a look here. 1 is going to go there. I'm just going to type in random numbers, to be fair with you, see what happens. He's going to need to go there. He's going to need to go there. Let's say 6. He's going to go there. He's going to go in number 7 to block him, and then number 9. And it's going to say it's a draw, which it is because now the game is completely full up and there's no spaces left. So that's working. I mean, that's pretty awesome, right? You now have a game that you can actually play with your friends, XO, that you programmed yourself. So there's plenty of things we could add to this. We could tidy up our code a bit, or we could get the screen to clear itself so we only have one board on it at a time. But I'll leave them for you if you want to program them on your own, rather than dragging everyone through it if they don't. So in general, this is a really quite an awesome project, right? This is something much different to what we've done before, which has normally just been printing stuff to the screen. So you should be super proud of yourself for building this. So why not reward yourself by grabbing a friend or loved one and playing a good old game of tic-tac-toe. Either way, that brings us to the end of this section of the Python Bible on functions. In the next lecture, you can have a review of what we've learned and also get a taster for what's to come in the section on classes, which is going to be all about object-oriented programming, and it's going to take your Python skills to really a massive next level, like industrial level. So I'll see you in the next video.